For the first time in over 50 years, we're actually sending astronauts back to the moon. But get this isn't just a nostalgic trip. Not at all. This is about building a bridge to our future in deep space. So let's walk across that bridge together and really unpack what makes the Artemis II mission so incredibly important. Our guide for this journey is engineer and storyteller Julius Verne, who just nails the whole point of the mission with this quote. He sees Artemis II not as the final destination, but as the essential first step, that bridge that's going to carry us farther out into the cosmos than we've ever been before. And this brings us to the big question, right? We've been there, we've done that, so why go back to the moon now? What's the massive vision that's driving this whole thing? Well, the answer isn't on the moon itself. It's way, way beyond it. Here's the key thing to understand. The Artemis program isn't about planting a flag and coming home. It is all about creating a sustainable, long-term human presence on the moon. Think of it like setting up a permanent base camp at the very edge of the map. The moon becomes our proving ground, our workshop, and our launch pad, the absolutely essential stepping stone for humanity's next giant leap, sending people to Mars. Okay, so keeping that long-term goal in mind, let's zoom in on Artemis II itself. If Mars is the main event, then you can think of this mission as the final, super high-stakes dress rehearsal before the curtain goes up for real. So what is it exactly? Artemis II is the first time since all the way back in 1972 that astronauts are going to head out toward the moon. Its #1 job is to be a brutal, real-world stress test of the Orion spacecraft. It's all about pushing the technology and the crew to their absolute limits out there in deep space, making sure everything is 100% ready for the even longer, crazier journeys ahead. The mission itself follows a pretty clear 4-step plan. It all starts with a mind-blowingly powerful launch and a quick trip around Earth orbit to check that all the systems are good to go. Then it's time for the main event, a flyby, where the spacecraft will loop all the way around the far side of the moon. And through it all, it's just a non-stop data-gathering machine before making that final, fiery return to splash down back here on Earth. And this is where you really see the massive leap in danger. Most of human spaceflight, like trips to the space station, happens in low Earth orbit, kind of tucked safely inside our planet's protective magnetic field. Deep space, it has none of that. We're talking radiation levels that can be hundreds of times higher, and you are completely on your own, hundreds of thousands of miles from home. And that is exactly why these tests are so critical. On Artemis II, they'll be validating Orion's life support, the air, the water, everything in that super harsh environment. They'll be testing deep space navigation, the advanced shielding meant to protect the crew from all that radiation, and, just as important, they'll be monitoring how the crew themselves perform psychologically under that kind of extreme pressure. Now, to get ready for a mission this complicated, you can't just build the rocket and cross your fingers. You have to fly that mission 1,000 times before it ever even thinks about leaving the ground. And that's where some seriously advanced simulation technology comes in. It's a system called LENS. The best way to think about it is as the ultimate digital twin of the entire mission. It creates this incredible shared virtual space where everyone, engineers, scientists, the astronauts, can all meet up to plan, train, and troubleshoot problems in a simulation that is ridiculously true to life. And this is just how vital that tech is for safety. Inside this virtual space, teams can see and practice these incredibly complex orbital maneuvers. They can test their navigation and communication protocols again and again. But maybe most importantly, it lets them game out everything that could possibly go wrong. They can model challenges like radiation exposure, so they can figure out solutions long before they become a real-life emergency. But listen, you can have the best hardware and the most brilliant software in the universe, but at the end of the day, it all comes down to the most important, and let's be honest, the most fragile component, the human crew inside that capsule. This really sums up that high-stakes balancing act between risk and innovation. So for the challenge of radiation, the solution is advanced shielding and constant real-time monitoring. For the psychological toll of being so isolated, the answer is hyper-realistic training and collecting data during the flight to understand the effects better. It's all about designing solutions for every single known challenge way ahead of time. And that training is everything. The crew doesn't just read a bunch of manuals. No, they practically live inside these immersive simulators that copy the exact conditions, sounds, and feel of being inside the Orion capsule. This makes sure that when the time comes, they are mentally and physically ready for every single second of that journey. So, the tech's been tested, the crew is prepared. What's the lasting impact of this whole thing? Let's zoom back out for a second and look past the immediate mission. Beyond all the numbers and technical data, Artemis II is really an educational catalyst. It's a spark. Its success is designed to inspire a whole new generation of kids around the world. It's a global shout-out to what we can achieve, pushing students everywhere to get into science, technology, engineering, and math. Which naturally leads to the question, how can you, watching this right now, be part of this incredible human adventure? Because this journey isn't just for the folks at NASA, it really is for all of us. Well, Julius Verne actually has some awesome practical advice. You can follow the official NASA updates to get the real deal info. You can dive into virtual mission experiences to see how it all works. And hey, you can support STEM education right in your own community to help train the explorers of tomorrow. And that really brings us full circle. Artemis II is so much more than a test flight. It's the first carefully placed stone on a bridge that leads us back to the moon, then onto Mars, and who knows where else. And it leaves us with one huge lingering question. Once this bridge is finally built, what are we going to discover waiting for us on the other side?